Good noon to everyone. Today discuss about in the mass transfer operation 1, unit number 7, liquid extraction. Okay. In the previous section આપણે ક્રિસ્ટલાઇઝેશન્સનો મોસ્ટ ઓફલી બધું જોઈ ગયા છે. ન્યૂ ચેપ્ટર સ્ટાર્ટ કરી છે લિક્વિડ એક્સટ્રેક્શન. આપણે હવે ઇમ્પોર્ટન્ટ પોઈન્ટ્સ જોઈશું મોસ્ટ ઓફલી. તો ફર્સ્ટ ઇન્ટ્રોડક્શન પાર્ટ. લિક્વિડ એક્સટ્રેક્શન સમટાઈમ કોલ્ડ સોલ્વન્ટ એક્સટ્રેક્શન કહીશું એને આપણે. Liquid extraction is sometime called a solvent extraction. Is the separation of the constituent of a liquid solution by contact with another insoluble liquid. હવે શું કર્યું છે, જ્યાં જે સબસ્ટન્સ જે લિક્વિડ કોમ્પોનન્ટ્સ છે જે બેમાં મિસિબલ નહીં થાય એટલે કે ઇનસોલ્યુબલ, બરાબર, જ્યાં આપણને બે લેયર જોવા મળે. સિમ્પલી એક બીકર છે, એમાં હું લઉં છું ઓઇલ અને વોટર, બરાબર ને. તો એના એક બે લેયર જોવા મળશે આપણને. એક ઓઇલ અલગ જોવા મળશે અને વોટર અલગ જોવા મળશે. Now, if the substance constituting the original solution distribute themselves differently between the two liquid phases, a certain degree of the separation will result, and this can be enhanced by use of the multiple contact of their equivalent in the manners of gas absorption and distillation part. A simple example will indicate the scope of the operation and some of its characteristics. In a solution, acetic acid in water is agitated with a liquid such as ethyl acetate. Some of the acid but relatively little water will enter the ester phase. Since at equilibrium the densities of the aqueous and esters layer are different, they will be settled when agitation stops and can be decanted from each other. Since now the ratio of acetic acid to water in the esters layer is different from that in the original solution and also different from that in the residual water solution, a certain degree of separation will have occurred. This is an example of a stage-wise contact, and it can be carried out either in batch or in this continuous fashion part. The residual water can be repeatedly extracted with more ester to the reduce the acid content still further. We can arrange the countercurrent cascade part. Stage-wise operations છે. Now the another possibility is to be used some sort of countercurrent continuous contact device where distract stage are not involved. The use of refluxes as in distillation may enhance the ultimate separation still further. In all such operations, in the solution which to be exerted is called the feed, and the liquid with the contact જે સામાં થશે સોલ્વન્ટમાં કનેક્ટ સોલ્વન્ટ હશે બે લેનની વચ્ચે આપણે એડ કરીશું. ઇઝ અ થ્રી કોમ્પોનન્ટ insoluble phases. The solvent rich product of this operation is called the extract, and the residual liquid from which solute for the removed on the raffinate phase also. Simply બે phase જો આવશે, simply reactions A plus B, બરાબર, give to C plus D, જેમાં આપણને extract phase મળશે અને raffinate phase adding a solvent part. Now more complicated processes maybe two solvent to separate the component of a feed, for example para and ortho nitrobenzoic acid. Can be separated by the distributing them between the insoluble liquid, chloroform and water. The chloroform preferentially dissolve the para isomers and the water and the other isomer also. This is called as a double solvent. Now the field too useful and unless the applications of liquid extraction fall into several categories. Those where extraction is direct competitions with other separation method, those where it is seems inequality qualified in competition with other mass transfer operations. Here relative costs are important. Distillation and evaporation part are direct separation થશે એનું. ઓકે સિમ્પલી હવે મેઇન આપણે ઇમ્પોર્ટન્ટ પાર્ટ જોઈશું. Liquid equilibrium extraction involves the use of system composed of at least three substances, and although for the most part the insoluble phases are chemically very different, generally all three components appear at least some extent in both phases. The following notation scheme will be used to describe the concentration and amount of these ternary mixtures for the purpose of the discussing both equilibrium and material balance. Now the notation scheme A and B are the pure substantially insoluble liquid, and C is the distributed solute. The mixture to be separated by extraction are composed A and C compound. Okay, solvent માટે એડ કરીશું. Now the E is equal to mass upon time of solution. Extract phase માટે shown on a phase diagram by the point E, and the mass per time of solution are raffinate shown in a phase diagram by point R. The B is equal to mass per time of solvent B. The solvent free quantities are indicated by primed letter. Thus will be the E dash is equal to mass be free such solutions per time shown on a phase diagram. Okay, this is a not important part. આપણે important જોઈશું. આયરુઆ important છે. Equilateral triangular coordinate system એમાં ત્રણ component હશે, A plus B plus C એનો ternary diagram આવશે. આ ટાઈપનું નોટ ડન કરી લો એકવાર. These are used extensively in the chemical literature to describe graphically the concentration in ternary system. It is the property of an equilateral triangular system. The sum of the perpendicular distances from any substances for any point within the triangular coordinate system are the three sides. ત્રણ બાજુ આપેલી છે ને AB, BC અને CD. AB, BC and AC represent a 100% composition, and distance to be the three sides. The percentage and fractions of the three component. Refer the figure 10.1 જે આપણે જોઈ તમે ડ્રો બી કરી છે. તો each apex of the triangular represent one of the pure components as a mark, and the perpendicular distance from any point such as k to the base AB represent the percentage of C in the mixtures at K, and the distance to the base AC, and the percentage of B, and to the base CB the percentage of A. Thus xk is equal to 0.4. Any point on a side of the triangular represent a binary mixtures. Point D for example is a binary containing 80 percentage, the 20 percentage of B. The all point on the line DC they represent a mixture containing the same ratio of A to B, and they consider as this point A, B and C. All discussion જોઈએ આપણે જો is A, B અને C ની ત્રણ બાજુ છે CB, AB અને AC. અને perpendicular distance કેવું છે K. એની ત્રણ બાજુ આપેલી છે આપણને this one અને this one. ઓકે, સિમ્પલી ફિગર આપણી છે આપણને ઇક્વિલેટરલ ટ્રાયંગ્યુલર કોર્ડિનેટ સિસ્ટમ. એને કહેશું આપણે ટર્નરી ડાયાગ્રામ. હવે મિક્સચર ઓરિજિનલી at D to which C has been added. If R kg of a mixture at a point R is added to E kg of a mixture at E, the new mixture is shown on the straight line. The RE at a point M such that R by E is equal to line ME by line RM is equal to XE minus XM by XM minus XR for inverse. Okay, for alternatively the compositions corresponding to the point M can be computed by material balance as will be shown later. Similarly, mixture at M, capital M base, has removed from in a mixture of compositions part E, and the new mixture is on the straight line EM. જો ફિગરમાં જુઓ this line. Okay, simply is a line ME by line RM, straight line જોઈએ આપણે ME. And alternatively the compositions corresponding to the point M can be computed by material balance as will be shown in the later. Similarly, if a mixture at M has removed from in the mixtures of compositions, the new mixture is on the straight line EM extended in the directions away from E and located R, so that equations applies. For equation 10.1 ના બેઝિસ પર જોઈએ તો establish refer to the figure 10.2 which again shown R kg of mixture at R added to A kg of mixtures at E level na basis par. Let M represent the kilogram of new mixtures as well as the compositions on the figure. Line RL weight fractions છે, C in R is equal to XR. Line MO is equal to weight fraction C in M is equal to XM, and it is equal to weight fraction C in E XE, a total material balance. तो इक्वेशन શું છે R plus E is equal to M. તો a balance for a component C, the line RL, line ET and line MO એટલે R plus E is equal to M. ઓકે, હવે ફિગર 10.2માં આપણે જોવાનું છે ખાસ. હવે એલિમેન્ટિંગ M is equal to M we get R by E, અને કમ્પોનન્ટ સી માટે જોઈએ તો RXR plus EXC is equal to MXM આવે છે. તો R by E is equal to line ET minus line MO by line MO minus line RL is equal to XE minus XM by XM minus XR. but line ET minus line MO is equal to line EP, and line MO minus line RL is equal to line MK is equal to line PS. Therefore, R by E is equal to line FP by line EP by line PS is equal to line ME by line RM. The following discussion is limited to those type of system which most frequently occurs in a liquid extraction. Some operations na basis पर છે. For a complete consideration of the many types of system which may be encountered, the students is referred to on the more comparisons. Taxis on the phase rule. Okay. So thank you so much. This system is completely over. Is this on figure.